Hello, and welcome to the first video in a series of introductory videos for Python. My name is Kat Webb, and I'll be introducing you to the concepts behind Python, how to use it, how to install your IDE, and a variety of other useful concepts. For now, though, I'd like to say a few things about Python. First of all, this is an excellent starting language because it's a lot simpler to write in than most programming languages like C++ or Java, and it's closer to spoken language than any other programming language I've written in. It's not like perfectly equivalent to written or spoken English, but it comes a lot closer than any other programming language I've seen, which makes it excellent for beginning users. It's also very flexible in its data types, so you don't have to declare them and use them in the same rigid way that you would in other programming languages. That's something that we'll discuss in further detail as we go on with the video. It also has a huge range of usability. You can use it for data science, you can use it for automation, which is what I used it for, or web development, or other desirable skill sets. So once you learn to use this tool, you can use it for many different things. It's like a Swiss Army knife. Python also boasts one of the largest libraries of all programming languages. A library is kind of like a library in real life. You can pull code from other people's written code and use it in your code in a way that allows you to have a wide range of tools. So that's where you're able to get that flexibility for data science or automation from Python. It also comes pre-installed with IDLE, which is an IDE or an integrated development environment, which comes with useful built-in tools like a debugger, code editor, and compiler all in one. IDLE will be used for everything we work on here, but I would really recommend looking at other IDEs like PyCharm or anything else you might have in mind, just because IDLE is very basic, so it's a great starting point. But as time goes on, you're going to want to be able to use those tools and just investigate for yourself how IDEs work. Finally, programming is like riding a bike. You can watch 1,000 YouTube videos, but you're only going to understand so much about riding a bike from watching someone else ride a bike. You have to try out the exercises and practice sessions for yourself, so I highly recommend pausing the video when you do or don't understand something and just typing it out for yourself. Python and IDLE are nothing to be afraid of. They're super cool tools, and I'm excited to get started with you. So with that being said, let's go ahead and get into installing your IDE and getting everything set up. So when you want to install Python and IDLE, what you're going to do is you're going to go to python.org. This is .org because Python is open source, which means anyone is able to look at it or use it for both commercial or regular community use. I would say that's one of the best things about Python because it makes the community so large and there are so many developers that want to work on this software. You should check out the documentation. Anytime you have any questions, this is going to be your holy grail to start out with. I know that when you Google a problem, a lot of times websites like Stack Overflow or things like that might pop up, but it's important for you to understand that those sites aren't regulated the same way that the official Python docs are regulated, which means the answers aren't verified by language developers and could be completely right, or they could be completely wrong. So it's important that you start with the documentation before you're able to really censor those things for yourself. Until you're a more advanced programmer, I would say you really want to follow these beginner's guides. They're excellent for just getting you started if you don't understand anything that we're talking about in the video and you just want a little bit more details. That being said, let's go ahead and install Python. I'm going to click back into Python here, and we're going to go to Downloads. So if you have Windows, they make this real easy for you, and you can just click that button there. But let's say that you have something else. We can go to the full list of downloads and come in here. Since I have Windows, I'm going to go ahead and hit the Download Python button. And in just a second, there we are. So I'm going to click in here. And it's up to you, but you could probably just hit Install Now and be done with it. The only thing, though, before you do that, is you want to click Add Python.exe to path. This is very important, especially if you're running a script, because scripts they need a path in order for them to work. And you can either specify the path yourself, which means you manually enter the entire file path from the Python program all the way back to your C drive, or you can add python.exe to path and it will automatically do it for you. I would highly recommend doing that. So anyway, click that button. Going to go ahead and install now. It's going to ask if you want to make changes to your device. I'm going to go ahead and hit no on this just because I already have it installed. But once you do that, it's going to go ahead and install for you. And then we're going to be able to open it. Now, if you try to open Python, that'll be an issue because we're not really wanting to open Python. That's not the editor. What we're wanting to open is idle. So go ahead and enter idle and then open it up. And once we get it opened up, I'm going to go ahead and start some basic scripts with you. Okay, so now that we've gotten Python installed, my first instinct is to try and open it. However, it's important to keep in mind that Python is the programming language that you're writing in, not the IDE you're writing in. So if you want the chance to play with it, you're going to want to go ahead and open idle. So I'm going to open it, and you can see it opens up to this screen with the 3 chevrons. That means that it's an interactive mode. There's 2 types of Python interactive mode with idle. There's the direct interactive mode or shell mode here, and there's also the script format. The script format allows you to write multiple lines of code and save your code permanently. However, the shell version is great because it compiles in real time, which means you can immediately test out a line of code. Honestly, I would say the interactive shell is much, much slower than running a script, and I wouldn't recommend using it nearly as much as I would recommend using script mode because you can't save anything that you're doing. So if you want to remember or keep any of the code you're writing, I would not recommend shell. It's just for a quick test. However, we're going to go ahead and play with it a little bit just because it's fun to get your feet wet before you start writing scripts. So I'm going to go ahead and print hello world for you here, which is the first thing that we do whenever anyone tests out a new programming language, generally speaking. Let's go ahead and do that. Now, print is a function. We're going to get into more detail on that later, but what you need to know right now is that print takes an input and makes an output. So given that we gave it hello world in our parentheses here, what do you think we're going to get? We get hello world printed out to the screen. So now let's go ahead and try a mathematic question. I mean, I can type out hello world by myself, right? But I don't always like to do math. So I'm going to go ahead and just type in an equation here. Let's see. This is one that I wouldn't necessarily want to do. Oh, and there's our first syntax error. So these things happen. It's very common. Oh, yeah, it's very common that you make a mistake in Python and it doesn't work just right on the first try. So don't be afraid if that happens. In this case, it was my fault because I tried to do both multiplication and division at the same time, which is not possible. And that's why I have a computer do all my math. But you can see we ended up with a number pretty close to 4, which is, we started with 4.2. So that's interesting. Anyway, it can process math for you in real time. You can test a function with it, like that print hello world that we did, but really you're going to want to use it for really, really short things, 1 to 2 lines. If you're going any further than that, you're going to want to open up your script mode. So let's go ahead and do that. I'm going to go ahead and go File here, New File, and bam, there's our script. So in just a second here, we're going to get started on writing with scripts. So I didn't really mention or use variables when we were working with our compiler because it was compiling everything in real time. However, now that we're working in scripts, it's going to become more and more important that you start using variables. So first of all, let's talk about what a variable is. A variable is a bucket, basically, that holds information for you and allows you to recall it later or change it in some ways and basically process the information that you're working with. To start, let's go ahead and just create a basic variable here. Let's call it string equals hello world. And you'll see why I'm calling it in a string in a minute, because this is a string. And let's say we want to change it in some way. So first we're storing it in this bucket string, and we're saying take the string in quotation marks, hello world, and store it in the variable named string. And now we're going to say, let's do string equals string plus height. And then if I save this, say intro file, and run that, what do you think we'll end up with? Oh, I didn't print it. Yeah, okay. So if I say print string, and now I run that, we end up with hello world hi, because we did something called string concatenation and we edited our string. But that whole time it was holding hello world, and then when we did string plus hi, it became hello world hi. So if I were to process it in some other way, it would continue to be hello world hi because it's holding that whole thing in its bucket. So now that we have the general idea of a variable down, it's going to be a little bit obscure, but it'll become clearer the more we work with it. And if you want to kind of take a minute to play with it, go ahead, play with strings a little bit. But the first thing we're going to talk about is a string. So strings are just text. They could be letters, they could be numbers, they could be just one single character or entire sentences or paragraphs. The most important thing about a string is it's got a quotation mark at the front and a quotation mark at the end. It could be 1 or 2 quotation marks, but it's got to be consistent. You can do 2 and 2 or 1 and 1, but you can't do 1 and 2 or 2 and 1. So let's say I wanted to do a numerical string here, which is, I mean, it's still just a string, but 24. See how it's the number 24? However, it's still a string because it's in those quotation marks. Strings are the most common variable type. I know that might sound surprising to you. It's probably the one that you're going to use the most, even if you're processing numbers, because on the surface, yes, you're using numbers, but whenever you pull them from another file or you pull them from a different source, which we do all the time in Python, you have to pull them as a string first and then convert them into a number from there. So understanding string processing and the way that strings work is paramount to using strings and processing numbers in an efficient way. Let's say I want to know how long a string is. I could do something like print. So I'm nesting functions here, which is a little more complex, but I've got len, which means find the length of the string, and then print, which means print out the length of the string, which is right here. Go ahead and count it if you like. It's a little bit of a trick question, but we'll get into that. So in computer science, a lot of times we start with the 0th character. So if you said 14, I would understand where you got that from. But length is actually counting the number of characters. So it's going to start at 1 here, and then we'll end up with a total of 15. But that's one way that you can find out how long a string is, which is important if you need to know, say, the length of a number or how you're processing that data, making sure that it's got the right kind of information in it. Another thing we can do with strings is we can index them. So if I wanted just the first character of hello world, you know what I would do for that? I would, let's see. I got my word, but this is indexing. So I'm going to take, in this case, the 0th element because we're starting at index 0, which is here, since we start from 0. And I'm just taking that one and saying print that out. So we end up with just H. But that is an integer right there, and it'll only let you have an integer in that spot. We're going to talk about integers now. All right, so we talked about strings and how those work, and now we're looking at integers. So an integer is a whole number. Like in this case with the index, you couldn't have half an index, right? I couldn't say 0.5, which would be like somewhere in between the H and the E. That's not how that works. You have to have a whole number. The example that I usually use for integers is a dinner party. So if I'm inviting people to my dinner party and someone says, how many people are you inviting? If I say, I'm inviting 15.5 people, that would look really weird. You should invite whole people to your dinner party. So let me go ahead and start with people here. Notice no quotation marks. This is not a string. This is an integer. So we don't use quotation marks when we're working with ints. And now I'm going to go ahead and process it. So I can change this, right? I can say, I can invite someone to my dinner party by doing this plus equals. So this means take my total people that I currently have and add 1 to that. So if I print that, what do you think we're going to get? What is people holding now? 16, which is different from the number in Hello World. I know it kind of looks similar, but yeah, 16 people. And then let's say we can do all sorts of arithmetic processes, as they would say, with our integer. So let's go ahead and uninvite someone. You could do people equals people minus 1. So if you're not doing the plus equals or minus equals, make sure that you write the variable on the left-hand side. We're always going to start with the variable on the left-hand side, and then an equal sign, and then however you want to change it. But you need to make sure that variable that you want to edit, or the bucket that you want that data to be stored in, is on the left-hand side, and then you assign it somehow. That equal sign is an assignment, so we're assigning a value to it. But Python can only process it if you put that variable on the left-hand side, which took me a long time to understand. This was my first language as well. So don't be afraid or upset if you find that you make that mistake, because it's a really easy mistake to make. So if we were to print people here, we would get 15 again, probably. I mean, we should. You never know with Python. Let's go ahead and run it and see. There we go. Went down by 1. All right. Now, if I wanted to do the multiplication, I could do print. Well, I want this to be permanent. So let's do people equals people times 2. So first we were here. Well, first we were here. Here's 15. And then we added 1. We printed that. And then we subtracted 1 again, which means we're back to 15. And now we're multiplying by 2. So when we multiply by 2, what do you think we're going to get there? I'm going to go ahead and take this out for simplicity's sake. We have 15. I'm also going to go ahead and take this out and just clean these guys up. And then print our latest people. You ever look at a word long enough and it doesn't look like a real word? Because people does not look like a real word to me right now. But anyway, when we run this, we get 30 because we got back down to 15 and then we multiplied by 2. So now, let's see, we can go ahead and do subtraction, or not subtraction, but division. But this is where things get a little tricky, because let's say that I divided people by something that didn't go in evenly. So let's say I did people divided by 8. 8's not going to go into 30, right? But we only want whole numbers. So if we only want whole numbers, we're going to go ahead and do those double slashes here, and you're going to see why in a minute. This is called integer division, and it's going to give me 3. Now 3 doesn't quite seem right. Let's take out one of them and do float division, and that's going to give us 3.75. However, 3.75 is not a working number of people. So we want that integer division, because if I said I can only take 1/8 of the people that I took before, it would not be 4, it would be 3. Anyway, those are some of the ways that you can process an integer, but it's important to remember that the 1/ is float division. It'll automatically do that, which is actually really nice of Python. Like, that is a feature, not a bug. And 2 divisions is going to do the integer division. Well, let's talk about floating point division. It makes me want to actually talk about floats, so let's get into it. Floats are floating point numbers, which is a way of saying it has a decimal. Now, floats can be whole numbers, which sounds weird, but when you say something like float, you can, well, yeah, it's a function, but you can have number equals 3, oh, no, not with the quotation, so 3.0, and that is a float because it's got a decimal right there. So this is an integer, that's a float, even though they're the same-ish number, which it's really hard for computers to store floats as entirely full numbers. Like, in all likelihood, this probably prints out to look something like that. Even though to us they're the same number, they are stored differently and processed differently. Let's see, some examples of floats. You probably are already familiar with pi, which is 3.14, and then many, many numbers after that. You could have a price on something, right? So usually you're not going to have a whole number. Just even if you did, you would have decimal points for the cents, right? So this would be another example of a float. Or if you had, here's an example we'll use soon, miles per gallon, right? So if you're probably not going to have just a full number for your miles per gallon. It's probably going to be 34.5. That would be great mileage. But anyway, some form of decimal mile per gallon. Again, it's kind of the same process with floating point numbers as it is with integers when it comes to processing. So we can say pi, we can just edit pi real quick. Pi plus equals 1, or you gotta let pi go back to its natural state. So pi minus equals 1. Just to be clear, you don't have to have a space right here. I'm doing that for readability, which I highly recommend you do, but you don't have to do that. It will still work either way. You can also do times equals, right? So the same way that you would process a whole number, you can also process a float. And division is easier. You can do integer division here, but generally speaking, you don't want to unless you have to end up with a whole number for some reason, but it'll be the same process. Pi. Right, so you can do that. You're going to end up with a whole number. So as long as you want that, as long as you don't want a decimal point at all, you can do it. But let's go ahead and run that. And even though it prints 9.0, what it did is it divided it as if it were an integer, and then it converted it back into a float. So it divided by just 4, and it cut this number off to be just a whole number, and then it divided the two of them. Floats are pretty interesting. You're going to be using them a lot, but one thing that you need to know is how to convert a float to an integer and an integer to a float. So let's say that all of a sudden I want people to be more flexible and I want it to become a float. I can say float people. And then if we print people, what do you think that will give us? I'm going to do the same with pi. I'm going to make pi an integer. So let's see. I'm going to do it all in one step here. Now it's important to remember when you're printing something, it doesn't actually process the variable the same way. So when I say int pi here, this does not mean permanently convert pi into an integer, which actually is the same that I did here. People equals float people. So now that permanently converts it into a float, but this does not permanently convert pi into an integer. So if I were to print pi on the next line after that, what do you think pi would be? All right, let's take a second to think about these three, and I'll go ahead and run it. So let's look at our last 4 prints, because those are what we're working with here. So the first one is we're printing pi, which we did that integer division, but we still end up with a float, 9.0. And then if we float people, we're going to end up with a decimal point number. So here's 30.0. Notice how it's still quote unquote a whole number, but it's got that decimal point in there. So now it's a float. And if we print the integer version of pi, or however we edited pi, we end up with 9. No decimal point, no nothing. It's an int now. However, it's not permanently an int, because what we did is we printed the integer version of pi. So when we print pi again, and we say, well, what's actually in pi? It says, oh, it's still a floating point number. It's 9.0. So it's kind of interesting how you can manipulate integers and floats and switch the two of them, but we're definitely going to be using that a lot. It's something that you should study and practice and keep in mind. So now I'm going to start with the data type that is the most abstract to us and the most basic to a computer, and that is a Boolean. So Boolean is kind of weird. It can be one of two things. It can be true or false. Also, I'm going to go ahead and clear this out because it's getting a little complex. But let's say I want to ask a question, right? So I can say is, oh, it doesn't want to let me type now, is logged in equals true, or has permission equals false. And that way I'm going to ask a question of the computer, and the computer will have a status at the time. So a true or a false. And you can use that status to make your decisions. You also can use Booleans to check a mathematical equation. So let's say I said print 5 is greater than 3, right? Or if I wanted to check a string, so the 5 greater than 3 is a little self-explanatory, but if I wanted to check if A is greater than Z, computers have a numerical value assigned to each character in the alphabet. So for simplicity's sake, let's argue that A is 1 and Z is 26, even though they're not really that in Unicode, but we'll get into that later. It's comparing, is this number higher or lower than this number? So in this case, it's probably higher because it's further down the alphabet. Let's go ahead and run it, see what it says. Yep, so we get true and false. You can also use Booleans in more complex checks. So you could say print is logged in, and so for an and, both the first characteristic and the last, or the first characteristic and the second characteristic have to be true. So the and is going to check, are these true and true? And if not, it's going to fail it. We should get a false. There it is. And then we could check it again. We could say print is logged in or has permission. And now it's saying if either of these are true, go ahead and mark it as true. Which for is logged in and has permission, we wouldn't necessarily want that because those are two different things. But let's go ahead and run it and see what it outputs. We get a true now because we have that or. So the and or are kind of linking concepts. They work together to link Booleans and check if each state is true or false, and then make a decision based on what those two say. I know Booleans probably seem a little bit abstract right now, but they're going to be used all the time in loops, in checking if something is true or not, in checking whether or not it's okay to process a file. Once we get into file handling, Booleans are going to make a lot more sense to you. So just hang on for now. I'm probably not going to play with these with you just yet. We're going to probably do some programming after this in integers, strings, stuff like that, and then we'll come back to Booleans when we get into our section on loops. Since we've gone over all of the basic data types now, I think it's really important that we start some housekeeping rules before you get into programming. A lot of programming is readability, really, making sure that other people can read your code or that you can read your own code if you need to come back in and edit something later. And it really comes in handy to have a structured format that makes sense and is legible and easy to use. Also, one thing that Python is really a stickler about is indentation. So we haven't worked with any indentation yet here, but if I were to create, say, a function, like let's see, if, well, this isn't a function, but it's a decision structure. And you can see here, Python went ahead and indented itself. Now that's key because Python doesn't have what we would normally use for structuring, like brackets. It has indentation alone. So you have to have perfect indentation if you want your program to work correctly. Python is going to keep you honest with the indentation, and it'll probably make it so that when you're writing in other languages, your indentation is good as well. But one thing that Python does not police that I'm going to tell you you should do is commenting your code. So let's say this block of code took me a while to figure out. I had to think about it, and I want to make sure I remember what I was doing there. I'm going to use a hashtag or pound symbol depending on what generation you're in, and then I'm going to write, I mean, it's kind of self-explanatory here because my variable names are making sense, which that's another topic, but I'm going to write an explanation for what I did above this code. Generally speaking, in computer science as a degree, we tell people every 5 lines or so. Really what that means is at least once per function, explain what it is that you're doing so that when you come back to it, you can kind of just say, oh yeah, that's what I was working on. And then what I was talking about earlier with your variable names being self-explanatory, right? Like if I were to change this variable name, or if I said, Q equals 10. What does Q equals 10 mean on its own? Is it quests? Is it queues? Like there's a million things that Q could be. It means nothing by itself. But if I were to say like quests, right? I have 10 quests that I have to get through. And then when I'm using this variable in my code, like for I in quests, that makes a lot more sense than for I in Q. So make sure you're being mindful of the variable names that you're using, because those are really important to understanding your code later as well. They should explain themselves, and if they don't, you should be adding comments to indicate what they are and what they're doing. But good code is always going to be readable. Another thing is, in some languages, they will tolerate writing everything in one line and being quote unquote efficient. Now, efficiency is important, don't get me wrong, and eventually we might go into data structures and how you can store your data efficiently, but A, in Python, you're probably not going to be writing in Python if you're trying to have maximum efficiency, and B, it is always more important that your code be readable to yourself and other people than that your code is efficient. That might be a little bit of a controversial thing to say for some people on the internet, but in my opinion, it's much more important that you always understand what your code is doing so that you can edit it later than that your code is all in one line or is super efficient and the most time efficient it possibly can be. Alrighty, now that we've covered that, let's go ahead and write your first program. So we have written some code here, but generally when we think of a program or algorithm, we're thinking of something that takes an input and gives an output. Now we're not going to take an input just yet, but we are going to try out handling some data here. So your first program that I want you to write is going to be, let me make a comment here. Print hello world, your first name and last name. And the area, oh, and then calculate the area of a triangle, sorry. And I know you didn't come here to learn math, so the area of a triangle, that formula for that is 1/2 base, times height. So I want you to think about this, go ahead and write out how you think you would go about creating this program, and then we'll meet back up. But anyway, you can pause the video. I'm going to go ahead and write this now. So start, I'm going to print hello world. And then I did tell you to print your first and last names, but I would recommend putting them in a variable because we're going to use that in the next section of this program that we write. So I'm going to go ahead and do that. I didn't mention it right at the beginning though, so it's okay if you didn't. Go ahead and enter that. Also, your variable names should make sense. See how I've got first name and last name. Oh, this is one thing, camel case. So usually we do the first letter lowercase, and then the next word uppercase. You can do that, or you can do underscores between your variables like this. Personal preference. I don't really care either way what you want to do. Just make it readable. Don't make it all one long word with no capitals and no underscores or anything like that. Make it readable. It's up to you what you want to do though. Some people really like camel case. Some people really like underscores. It's up to you. Anyway, the most tricky part of this is the triangle calculation. This is another section that I want to talk about housekeeping. So no magic numbers. What's a magic number? A magic number is when you just put a number in there and you don't explain what it is or store it in a variable that makes sense with the name or anything like that, which is bad. It's pretty much always bad to just have a random number in your equation. So let's say I wanted to calculate the area. I did area equals 0.5 times 15 times 25. What does all of this mean? You know, is this the base? Is this the height? And what is this an area of? Is this an area of a triangle? Sure, I have a comment up there and I have the 1/2 base times height, but let's say that I hadn't put that in there and explained that. If someone were reading this code, unless they already knew the area of a triangle equation, they would have no idea what this is. And even if they did know that, it's possible that they were calculating the area of a different shape and 0.5 meant something else. So we're going to do this the right way. This is the wrong way to do it, but I'm going to leave it as a comment just so you can see it. So let's say something like triangle area. And then I'm going to go ahead and create a variable for the half. Oh, and you can't start variable names with numbers. I hadn't mentioned that yet, but yeah, it won't let you do like 1/2 or anything like that because of the way that Python compiles. It needs to only have characters at the beginning, or not characters, but letters at the beginning of the variable name, and it will crash if you try not to do that. 1/2 times, let's go ahead and do base equals 10. Phil and Zany, height equals 15. Another thing that would be acceptable to do is to put base times height over 2. That would do the same thing, but you have to be careful how you do that, because if I did it like this, that means triangle area equals base times height divided by 2, and it's up to the compiler. Basically, when the program runs, the computer has a choice of which operations it will do first. Its order of operations, our PEM does, if you remember that. So the division sign probably is going to be on the same level as the multiplication sign, but we don't know that for sure. So we want to do, really, we want to do 1/2. That would be the most readable thing to me, but you could also make an argument that the parentheses work here. You can do that over 2 like that would also work. It's up to you what you want to do. Both of them are good, but just remember that. But I'm going to stick with my 1/2 times base times height because that to me is the most readable. Then we're going to print that. Go ahead and run it. Let's print triangle area. See if it crashes on me. Oh, and I wanted you to print first name. And then I'm going to go ahead and concatenate just to get real fancy with it. What I want you to think about is, what's the difference between the print first name and last name as 2 separate lines, so print and print, versus print first name plus last name. How do you think that's going to look different from one another? And we'll come back to that. So I'm going to give you a little shortcut, which is Control S if you're on Windows, or I believe Command S if you're on Apple. Will save your program for you. When you're running a program quickly and you're testing things out and you want to be able to flip back and forth quickly, that Control S will save you more time than you realize with that pop-up that says, do you want to save? Anyway, went ahead and ran this, and we ended up with 75, which is correct. Yeah, that's correct. And then I never know with Python. And then cat web, all one word, and cat web, 2 separate lines. So when you do a print statement, it has a silent end line on it, which an end line is what it sounds like. It ends the line and moves you on to the next one. So this is really cat end line, web end line, and then the next one is all one word because there's no space. I didn't put a space between the two of them, and there's no end line in between the two of them in the plus. There's no end lines internally in the print. It's just added on implicitly to the end of whatever you print. So there's our first run. Hopefully you got 75 if you tried these guys out, but we could change them. Wouldn't it be nice though if we could let a user input stuff and write their own name and not our name, and also let them calculate their own triangles area? We haven't seen how you would do that yet, but I'm going to go ahead and teach you real quick. So if we want to ask someone for information, we'll use something called the input function. Except I want to store it somewhere because input is great, right? But it won't store anything in a variable unless you tell it to. So this, ooh, I want the question mark in the quotations, thank you. This takes an input, but it won't save it anywhere. So if you want to save it, well, that's a little long for a variable name, but that's fine. I would say, you could say first name if you want it to overwrite your current first name, but if you don't, you could say something like other first name, and then it'll take an input, and then let's print other first name and see if it knows what's in other first name. Run that. And you can see it's got, what's your name here? And then I'm going to say it. It's cat. And then it prints cat again. Now, if I wanted to run that and put in someone else's name so that it doesn't look like it's just doing mine, give it Bob. There it is. Bob's in our program now. So I want you to go ahead and try this guy again using those input statements, and we will check if you're right, but I bet you can do it. If you come from another programming language, you might have noticed that it just allows you to assign a variable to an input, which normally it doesn't do that. Normally, well, not it. Normally a program will insist that you specify what data type your variable is, depending on what language you're writing in. But in this case, it doesn't require you to. So when I go ahead and rewrite this, I don't need to store something in first name and last name before I take the input. I'm going to go ahead and leave print hello world as it is because it's never going to change. That's just the string that it is, right? But if I wanted to ask someone what their first name was, I would use Bob's line here, right? So I might cut and paste that because it's a little more convenient, right? As little as possible, right? It's okay to reuse code where it makes sense. Although we don't really want to be copy pasting a lot of the time. That's going to be a loop, but in this case, it's okay. So we're going to go ahead and say input again. Oh, except this is for just your first name now. And then we're always striving for readability. So these are good, but I'm going to go ahead and add in a space here. These pluses allow you to concatenate strings while you print them. Mind you, it won't actually concatenate them permanently. So this is not going to become Katrina space web, right? Or that's my full name. But anyway, let's say I wanted to do like total name. Oh, whoops. Total name equals this instead of the print. Now it would permanently concatenate into total name. So first name would still be Cat, last name would still be Web, if that's what had been stored in there before. And then total name would be Cat space Web. But you have to be really specific about how you use your concatenations here and what function you're using it in. We don't need total name, so I'm going to go ahead and just print this concatenation because it doesn't really have to stay forever. I just want it to print out that way. Now the triangle gets a little bit more complicated. I mentioned this to you earlier when we talked about integers, but anytime you read something into Python, it comes in as what data type? A string. So base being equal to an int right away and height being equal to an int right away is not going to work. We could leave them like this and then just change them once we take the input. But, I mean, you don't really need to. It takes up extra space. So I'm going to go ahead and change this. Start with the part that makes the most sense, which is the input, right? Oh, there's a space there where I don't want one. But now we need to convert it. And I don't really want an integer because I might want to be able to do decimals if I'm calculating the area of a triangle, right? A triangle might not be a whole number side. So I'm actually going to use the float function here, and it's nested with the input function. So we can see here, internally it's saying first take the input and find out just what's the size of the base, and then convert the whole thing into a float. Make it a number with a decimal point. We're going to do the same thing for height. I am just going to copy paste this for the most part because it's the same thing. And we save time where we can. Be as lazy as possible by automating what you don't like. We are going to leave 1/2 the same because it's constant, right? The same way that hello world is never going to change. That part of this equation doesn't change regardless of what input you take. So we're going to say 1/2 equals 0.5, and then we're going to print these two, or take the inputs here, and then calculate, and then print here, and other first name is nothing now. So that would crash the program. But let's go ahead and run that, see what it says. Oh, and there's the must be saved. So that's where your Control S comes in. And there we go. Now I'm probably going to run this again with decimals there just so you can see that it could potentially end up with not a whole number. Let's do that. There you go. And it comes up with this long number. You could tell it to round to a specific number. We'll get into that later when we're specifically talking about how to handle numbers in larger calculations. But for now, you can see it'll just give you a certain number of decimal points unless you specify exactly how many you want with the formatting function. One thing I want to mention is that Python can't really mix data types inside of a function implicitly. So like, let's say that I wanted to say, oh, first name, your triangle is such and such size. It can't do that with the string staying the way it is and the number staying the way it is. So we're going to have to convert the number into a string because strings that aren't numerical aren't going to convert into numbers properly. They will throw an error. So we could do print. No, that's lowercase. Like if I try to do this, just be very blasé about it and do that. I can, but when I go to run it, well, it hasn't crashed yet because it hasn't reached there, but let's see what it does. Yeah, it does not like that I tried to concatenate or add together a string and a number. And it says, I don't know how to do that. You need to give me a string. What I could do Let's use the type conversion into a string. Now remember, this isn't permanent, so triangle area still will be a float outside of this. But if I go ahead and run it, whoops. Alrighty, there's that. And then it just added these two together, which if I wanted to, like we were saying earlier, you could say your triangle is, and notice how we need the pluses for each section, and I'm adding in spaces at the beginning of my strings because they're not included with the number or that preset string. We could have included it there if we said cat space, but since it's not there, I'm just going to go ahead and add it in retroactively. So let's do that, and then save this guy and run it. And notice how I also didn't include a unit here. I'm not really thinking about units, but I could say, like, let's say it's square feet, which would be a really big triangle, but it's okay. We'll make a baby one. There we go. So just remember, you need to make sure that this variable and this variable agree when you have them both in a function. So like print is a function, input is a function. You can take, I mean, you can't really take multiple inputs. You can take multiple inputs at once, but it's more complex than we're going to get into in this course, and it gets confusing quickly. I just recommend having them on separate lines. I think it makes the most sense. I know that this has been a lot of information and you're probably going to want to take some time to process it. So let's go ahead and do a quick recap on it. Maybe we'll take a little sneak peek at what's happening in the next video, and then we'll just go ahead and end it there. So today we went ahead and went over how to download Python, where you should be looking for documentation and information if you have any questions about functions, some basic data types, using a compiler versus using the script format, so the real time versus the script format, and then writing your first program, and how you should go about your housekeeping. So remembering your comments, definitely remember your comments, and then remembering proper variable names and good spacing. Next week, we're going to go ahead and talk about decision structures and loops and really expand your horizons on what you can do. So if I wanted to, say, check the size of the triangle, we could do that here with an if statement. And I'll explain. I know you've seen me use if statements a couple times in this video, but let's see. Here's an example where you've actually written the program so you'll understand what it means. So if and I'll throw in an else as well to make it real exciting. Make you want to come back. So here's that. If, and then when I run that, whoops. Oh, it didn't like my spacing. That's okay. It is very particular about spacing, which we talked about. So there we go. Since it's less than 100 square feet, which is a really big triangle, it tells me that it's a small triangle. And next week, we're going to talk about how you would go about making those decisions and setting up decision structures so that you can change the flow of your logic. Anyway, hopefully this has been pretty helpful and interesting. Please feel free to comment if you have any questions about it. And I'm excited to teach you some more. So have a good one, guys.